This time on JAIRUS of All, I play with an obscene amount of carbon fiber and nearly ruin it, but I pull it out in the end. If you think this project of a carbon fiber and titanium buster sword is really awesome, don't thank me. Thank my Patreon patrons, whose names are on my table. Without them, there's no way I could have afforded this build. It was far too expensive for me to do on my own. And if you'd like to join this fantastic group of people in supporting my channel and making builds like this possible, links in the description. It's only $1 a month. You get access to exclusive content, any digital files that I can send you from the builds that I do, and you get your name on the table, which will be updated by next video. I haven't had access to my vinyl cutter. But now, on to the build. Slight change of plans and a quick refresher on what I am about to do to create the internal structure that will support this blade. Cross section of the sword. Carbon fiber reverse taco goes here around the body of the sword. And then on the inside of that, it will have 2 layers of carbon fiber that go up through the center of the bevel. Those will wrap around the blade. The titanium at the tip has a taco of carbon fiber around that. And then instead of having these pieces come out and go to the sides, which you couldn't see in the last video because my framing was bad because I was doing it by myself, I decided that I would bring them down here and have them stop, but there's going to be a fillet of chopped carbon and epoxy to reinforce this section here. This is actually pretty complicated to put together because everything has to be clamped and held in place and it's all on weird angles, but I have everything very accurately cut, and I believe that I'll be able to get this all applied in a way that allows me to get it set up and not screw up all the work that I've put into the core. Here we go. Not counting clamps, there's 17 different pieces that need to be held in place accurately for this layup. I'm gonna use some fiber tack to hold some stuff in place to make this process slightly easier instead of trying to float 17 things together magically. This piece is getting taped in place temporarily. I ran out of the 2x2 twill that I'm using for the other core pieces. I need this piece to be nice and tight, that way my tolerances around the end here are correct. Blade is interesting because it has traction grooves for the carbon fiber to attach, and then it has the bevel on it, which will be revealed later. I need the taco to sit on it, but I can't epoxy the whole taco because I don't have layer separation between the exterior layers and the taco that goes on this. This needs wrapped with carbon, needs held in place, and I don't want to use the MT1 glue because I'm afraid that it could potentially reduce my bond strength here. So I'm gonna try to get this stuff to stay in place with tape. I made these wood plates with aluminum angle pieces to keep them perfectly straight. Everything's gonna get clamped together with this, but this really is the moment of truth. A lot of stuff you can redo, but composites, you basically have to do it again. So I'm about to take something that I've spent a huge amount of work on, try to make this work out. Like right there. Yep. Now we need to get the blade in the whole way. You see that? How it's like not in the bevel at all?
I just don't want to force it because I don't know where it's hanging up.
Down here, this section here.
Oh, okay, I see.
I'm just trying not to glue the boards to it. So you want this to come up to the top of the fiberglass, and then we gotta do the same thing while we're holding that for the other side. trying to make sure that the blade itself is lined up with the sword body, but there's so much stuff in the way, I can't tell, which I wasn't thinking about before, but I am now, because I can't see anything, so that's cool. Looks like the blade needs to go either deeper in or towards the back. Is it just not down in enough? Okay, that's better. This is ridiculous. Just a total show. Okay, push the titanium my way slightly. Now we're good. Okay. So it's trying to come out with the trough up. So now it's time for rubber bands, which is what I was thinking might be the issue, but I think we might be all right. I think this might work out. That sucked. That was harder than I thought it was gonna be. I think this may work. Like everything's kind of where it's supposed to be at right now, so. Well, now I need to move this to a very warm location for it to set up as fast as possible so that I can do the next step, which for you will take 2 seconds, and for me will take 2 hours of pulling my hair out.
2 hours later.
Oh man, she's lined up so nice.
That's wrong.
That was the biggest thing I was worried about, was the alignment of the bevel to the body. All right, so now let's see if this one will come off. This one's just not even, nothing holding it.
Nope, that's wrong.
At this point, the epoxy has just reached the point where it is just past gelled. And I wanted to pull this apart and see, especially I wanted to do this because I didn't want these panels that I used to be permanently affixed. I was hoping the paper towel barrier would at least give me something that would tear apart relatively easy, and it actually did work out pretty well. I'm gonna have to do some removal of some material on this, but not much. Not much.
Well, that's where you're wrong.
The biggest thing is the bevel is totally aligned with the body.
That's wrong. That's wrong. You're not doing good so far.
A few moments later.
It does look like the bevel is offset. This side, this is almost flat compared to this side. Looks like it may have shifted, which doesn't make sense because it should have been aligned from the tip. Like, that's what I was counting on. The blade itself is actually straight, so it's straight. How's the bevel off?
That's weird, man. That's weird.
Is it an optical illusion? I can't tell what's going on here. There's no way the bevel should be off if this is lined up with the point of the blade and the whole thing is straight. So it's almost like this canted to the side, to that side. It's good back here. I wonder if this part was just off. And how did that get off? Because that's not tight right there.
Bingo!
All the crap that I put on top of it, I couldn't see that this was off. And there's a good chance that I just ruined the whole sword.
Ruined.
We'll see what happens. Maybe I'll come up with an idea to fix it. But this is set up to the point that it's no longer modifiable, so it's time to let it sit and take a look at what's actually going on in the morning. And I have a fresh set of eyes to look at what I screwed up. My wrap on the blade worked out really well. That's perfect. I think no matter what, I'm gonna be able to finish it. It just won't be what I thought it was initially. I want to keep messing with it, but I shouldn't. I'll just wait till tomorrow.
Day 2.
By the time this thing was done last night, it was late, I was frustrated, and now that I have cleaned all of the stuff off of it, like little bits of paper towel and everything, I can get a clearer look at how things are lined up, and everything definitely shifted while it was clamped. I should have checked it more than I did. I felt like it was gonna be fine. It doesn't matter. What matters is, what's done is done. Now to try to fix it. I'm gonna try to give you the best idea of what's going on possible. This part is lined up. The bevels are correct here, but it is a hair off center. The titanium though, leaned a little bit to that side. Big issue is that on this side, there's almost no bevel. It's almost totally flat. Yeah, you can see. Versus that side, which is hysterical. So mostly this down here shifted while it was clamped. And because of that, the titanium is pretty stiff, but it's not, you know, that thin over that long. The clamping pressure was able to make that move. So that's messed up too. It's very difficult to show you at the tip. I need to be careful. I almost cut myself on it just now. This is centered in the foam, but it is leaned this way. The titanium is, the whole thing is rocked, which means that this part at the tip should be sticking over there, but it's not. It's actually too far to this side. Can I make you see that? It needs to be there. It's not. So basically at this point I have three options. I could rip this apart, mess a bunch of stuff up, try to put it back together correctly, which probably wouldn't work out very well. I could lay up all the carbon fiber on it as it sits and just paint the edges like I'm going to make it look like there's bevels on there and there just won't really be one on the other side. Or option 3 is try to polish a turd.
Okay, well, good luck trying to polish a turd.
I'm gonna do what I can to fix the issues that are there. The titanium is very mounted, so it will be a little cockeyed no matter what. I can't change that unless I rip that out. The plan is to clamp this down so that I can actually get measurements off of the flats, move this back to the center. I pushed on the bevel real hard and cracked it. Now I didn't crack the carbon fiber, I just cracked the connection between the epoxy and the foam, which is very difficult to see. It's on the underside of this, it's on the top side of this. If I clamp this down and I clamp the blade over, this part here separates. See that tiny separation? So if I clamp this down, I can fill that with epoxy to keep this in alignment where it's supposed to be, right there, and bring my bevel back. That's the first step in trying to polish this turd. And some of this material on the outside here might need removed because it is far too proud, which I don't really understand because the carbon fiber I-beam does come up both sides of it. You can see it on both sides. It should have been doing everything in its power to be centered because those pieces should have been pushing it to the middle. I don't know what happened. I really wish I could have seen more when I clamped it up, you know? Hindsight is 2020. You can't foresee every single little thing that's going to happen, especially when you can't see what's going on when you clamp something together. So I thought that it would stay in alignment, but it didn't. Time to fix. Trying to match that angle to that angle. I have bevel on it now though, and it's as tight as I can make it without. See it? Did you hear that? It's doing cracking noises every now and then. Pretty bad. Gonna mix up some 5-minute epoxy and use this syringe to try to inject it down into that joint right there. All of this is a little towards this side, so there's no ridge right there. There should be a slight ridge because that's the way the sword is in the game. Get this wet. Add a strip of carbon fiber here. Ooh, yeah. Cracking all over the place. See, now I'm getting a nice gap that I can fill with epoxy right there because it's all coming apart, which is good because that's what it needs to do. I put these little 1/2-inch shims just under, so it's just over 1 inch thick. So since I can't put this right on the edge of the blade, I have it tucked under the titanium just enough to keep it at 0.51. So the titanium is held in the correct orientation. If I take those out, the titanium just droops back down. Polishing the turd. There's hope. Not much, but there's some. I'll let this sit and cure. Now it's time to pull all this stuff off and see if it worked. I got my extra little layer of carbon to give me that little bump at the edge. I need to put one on here, but that'll only take a moment. It doesn't look like it's moving very much, so it may have held right where it's supposed to. Drilled a hole in the drywall to get a clamp right there. And fix that. The titanium is still off a tiny bit. Yeah, I think that did it. Question is, if I try to move this one at all, I don't think I'm gonna be able to. There's a little bit of an edge on here where this stuff's set up, so you can't see it. I can't see it. I can only feel it. There's a little bit of resin that made it up into this fabric here. If I push on it, it goes up against the titanium. I don't want that to be an air pocket. There's a little bit there and a little bit right there. But other than that, it's ready. I feel like that's a fair amount of effort to push that into place. I think I'm gonna have to stick some epoxy in there, just so that I don't have to worry about that, because that would give me this big goofy edge. Right before you'd hit the edge of the blade, there'd be a big bump out. But whenever I go to remove the carbon fiber from the blade edge on the titanium, it might reveal like an air pocket on the side of the titanium. Even if it doesn't, because the height that that's sticking up, if it doesn't get pulled down by the vacuum bagging and I sand this back to reveal the titanium, I might end up having to sand back a bunch of the strength layers that I put on, which would defeat the purpose of them, because if I sand them off, I don't have strength layers anymore. Can't afford to risk it. I had another idea. If I hit this with the heat gun, it makes the epoxy soft, and I might be able to bend it back into place. If I can get enough heat into that little spot right there, just enough to get it flexible, I can reshape it and I don't have to worry about screwing up that surface that needs to be bonded to the 5 strength layers. Snappy-doo! There's the other spot. Ha ha ha! It worked. I'm gonna heat and clamp the rest of the spots, and then I get to clear all of this stuff out of the way, and it's time to set up for the main event. All these materials came from COMPOSITE ENVISIONS, and this video is not sponsored by them, but they're a wonderful company. They ship fast, the packing quality was amazing, and when I called, I got a real person on the phone that answered all of my questions and helped me decide what I needed to do this whole project. And they didn't even think this project was weird, so that was extra cool. Anyway, like I said, not sponsored by them, but they're still open. Even now, if you want to try to do a composite project, I'd recommend using them. Great prices, wonderful customer support, and if you do use them, let them know that I sent you, because maybe they will sponsor me in the future. Before I start laying up carbon, I need to get all of these pieces cut and ready to go on it. They recommended I get the slowest setting resin, but that doesn't mean I'm going to try to waste any time. I didn't order enough release film because of the size change that I talked about in the first build, so we need to extend it a little bit. This is vacuum bag. This is peel ply layered with the little holes in it, and it releases the excess resin into this, which is bleeder cloth. This allows the air to flow out to the vacuum port, and it absorbs the excess resin. And then when you peel the peel ply away, this peels off, takes the extra resin with it. That way you get a really nice ratio of carbon fiber to resin. This extra bleeder, I'm gonna make a track down the middle of it where it's doubled to aid in the evacuation of the atmosphere out of the vacuum bag. This is my first time doing this, so I have nothing to base my decisions on as to how much resin is in it. I've done fiberglass before, but I've only done wet layup without vacuum bagging, which means I don't really know how this is gonna go. This is one of those fingers crossed moments. So this part will basically go like that, and this piece will be on the other side, and my vacuum port will be right here. Yep, I think it's time to start doing resin.
Moments later.
To make this layup as easy as possible, we're going to lay everything up with all the sheets underneath. One will get folded over, wet it out, fold back over that way, fold this one over, wet it out, unless it sticks to it, in which case, then we'll just wet that out. And we'll go back and forth until all the layers are done. And the peel ply is underneath it. Luckily, I have a friend that is in my group of people that I don't have to distance myself from, and he's gonna help me do this because I wanna get it done as fast as I possibly can, and having an extra set of hands is indispensable doing stuff like this. So here we go! And it's very cold in the garage. The resin's been sitting in a warm room at 82 degrees, so it is more than warm enough and thin enough to use. So once we get it laid out, it will actually cool off, and it'll give us longer work time, but it'll be nice and thin for right now. The guy at Composite Envisions told me that this is the way that I should do it. It'll give me a crazy amount of work time, but it'll still be easy to mix and easy to wet out the carbon. Got a drill mixer. It sounds like it's mixing it like crazy, but in reality, it is not, because it's set on the lowest speed. The motor is going nuts, but the mixer part is not. I always hated resin that stayed wet for too long, like that takes forever to set up, but this is really nice. I don't know if you're supposed to wear a respirator or not with epoxy, but this stuff has next to no smell whatsoever. If there is something dangerous that you're not supposed to breathe in it, it doesn't seem like it because this might as well be thick water. I'm sure somebody will let me know in the comments. This looks amazing. Holy cow. This stuff looks so good. Make sure it's super tight. See how that's lining up? It's gonna be identical side to side. It worked. It doesn't always work, but this time my math was correct, which, I mean, my math is usually correct, but it doesn't always necessarily work out because there's variances in everything. So life is not a math problem. The pattern on the hexagons lines up perfectly side to side. She's in her nice warm blanket now, boys. Reaching the end of the road. There have been many moments of truth in this build, but this is one of the biggest. It's time to turn on the vacuum pump and watch this bleeder material fill up with all the excess garbage resin that we put way too much of on. In the last video, I talked about how I was having problems with my vacuum system leaking, and it was because I just used some plastic to make a container around the receptacle that goes on this bag, and that was what was leaking. It was the plastic that I used. Apparently, some plastics are very permeable by air. Did not know that. This stuff is not. I did a vacuum bag with this, a real tiny one, and it didn't leak for hours, so. I hear leaking. Leaking. It wasn't the spot. You did a great job on the handle. It wasn't leaking at all. It was where I made that connection there. I hear nothing. There we go. It's in there! See you in 24 hours.
It's gonna feel like an eternity.
After one exceptionally long day where I had to stay up all through the night and all through the day to make sure that the vacuum that was in the bag stayed at the correct level, this thing is ready to unbag and get to find out if that effort is all for nothing. It's out and it's done. If you want to see a little more about it, you can watch the live stream that I did of removing this thing, but it's kind of still a turd. There's some problems with it when I pulled vacuum on it. It did dent the soft spots in the foam, so there are some dents in the blade. And there were a couple wrinkles that formed in the peel ply, which caused slight imperfections that are just superficial bits of resin that are sticking up. One side is substantially better than the other, but even though it's not nearly as flat as I thought it would be, the surface is very bumpy. But before I get to all the finishing work, I need to at least get the edge trim back to the titanium that's embedded inside so that I can get measurements for the 3D modeling that I have to do for all the stuff that has to go on this yet. I can't remember if I ever explained my vacuum setup. This is a special fitting that you get for vacuum bagging. It's 2 plates of aluminum, one goes through the other, and they twist together to clamp down on a ring of neoprene rubber to seal to the vacuum bag. Fittings that I got to put all this together, and this piece of steel rectangular tubing. Welded plates on the end and put fittings in, and then epoxied them in place just to make sure they were completely sealed. And this is a vacuum gauge that I got from the Harbor Freight. This tank was not necessary, but I did know that potentially you can get resin pulling through your vacuum port out of the bag if you have too much excess, and if it goes through, it can ruin your pump. Not sure if this is important, and it'd be great if somebody could tell me if this is true or not that has more experience with this. I read a document from a composites company that said that pulling more than a certain amount of vacuum can potentially push too much resin out of the fabric and make it dry, and then it'll be weak. I stayed around -5 psi or 10 inches of mercury vacuum. Maybe that's part of the reason why this ended up bumpy, and it probably could be lighter if I ran it higher, but I was afraid to because I would rather have a strong, slightly heavier sword than a slightly lighter, very weak sword. So your input would be very much appreciated. But now it's time to cut this thing. The best tool that I have for the job is just a Dremel with an abrasive disc, but it is nasty stuff. So you gotta get all sorts of protected. The resin can be toxic, the carbon fiber isn't, but the carbon fiber can irritate everything. I'm not trying to be itchy for the next week, so putting on all the things. So now I'm close to the titanium. Eliminated about an inch of sanding that stuff off, but now it's time to use the electric file to get back to my actual edge. Ooh, she's so sharp. See how the titanium is revealed? It's so sharp. You know I gotta try it. This could definitely be sharpened far more than it is currently, but... See that? Look at that. And it's starting to rip down there. It's hard to hold this sword and the paper at the same time. Oh, almost. Look at that. That is a very long, sharp piece of titanium. Oh, it looks really cool right there. The core, the handle, and the titanium piece were 2 pounds, 6.4 ounces. So once all the carbon fiber was applied, total weight was 6 pounds, 2.37 ounces. Come on, balance. What is your deal? Sit still. Why won't it balance? There we go. Lo and behold, it was the table the whole time. With all the carbon fiber sanded back, we are down to 5 pounds, 12.3 ounces, which means I removed 6.07 ounces of carbon fiber. So the whole sword, 19 grams to this point. This has been a huge amount of work with seemingly very little progress to get it to this point. Now is the time where it's not going to take a whole lot of work to make huge changes in this to make it look really awesome. Like sanding this back and getting UV resistant paint on it and doing the blade silver and getting the 3D printed material and the handle wrap and all that. Should come together pretty quick. It's definitely frustrating when you spend a huge amount of time on a project and you seem to make no progress. You stick to it, you put on all that time and effort, and you end up with a really awesome product in the end, typically. And if you don't, you can always just do it again, and you'll do it better the second time. Since I am close to making a lot of progress on this, I am extremely excited about working on it. Fortunately, I have to stop and edit this video. So, I'll see you next Sunday when I definitely finish this thing completely. Maybe even make a cloud costume, or parts of it. At least as much as I can do with what's available since all this craziness is going on right now. Thanks for watching. I'll see you next Sunday. Cloud poses or something. Is that a good thumbnail?